G'day everyone, Pete Techman Coman here, and I'm joined by my good friend Mark the Bearded Tech Scan, and we're at ISE 2020 in Amsterdam. And we have a very special guest, Mark. Who have we got?
Garth Lobban from Atlona. Thanks for coming on the show.
Thank you, Garth.
Happy to be here.
Yeah, thank you.
Right. And before we go any further, Garth, there's something we noticed.
Yes.
Can you just show us your watch?
What? Yes, I can.
He's got the
Company colors and everything.
And is there anything else that you might not be able to show?
Well, I have to admit, I did update the shoelaces for the show. They are bright.
Loving it. Can we get it? Can we get it? Here, look. Let me hold your feet up. There you go. Look at this.
Right.
Beautiful.
There you go.
Atlona orange.
And
that's right.
Nice effects.
Yes.
Should we ask what colour undies you're wearing?
You can. I think that'd be a great question to ask.
Don't answer it. That's all.
Well, I wasn't going to give you an answer. It's a proper question to ask after all of this branding.
Exactly.
But they aren't branded. I'll tell you that right now.
Yeah.
There you go.
Maybe you should be. You got to step it up.
Yeah.
There's a marketing opportunity
There
there.
is.
Hold on.
Oh, write that down.
Anyway.
Hey, why are we here?
Why are we here?
Because we're here. Roll the bones.
We're here at ISE 2020ty because.
And that's good. And it's always great to have a special guest when we're recording a segment. It's fantastic. Well, you got to jump in.
Hang on, Reto.
Hang on. Reto, if you're going to come in and disrupt our video, you have to do it properly, right? You got to. Hang on.
Yeah, we can do this. We can do this.
We could be now. We could be.
Make sure you're in
professional
recording. No, we're not professional at all. Good to see you again.
Hey, Grandma. We might have to do some musical.
With the mics.
With the mics. Yeah. You'll have to yell or anyway.
Yeah.
You can absolutely do that.
We'll keep rolling.
Yes.
That's the way we roll.
Would we have it any other way?
That's the beauty of live TV, right?
Yeah.
That's right. That's right.
So back to where we started before Reto come and joining the party. We're here because we want to unpack AV over IP and start to demystify some terms, things for integrating. The 1-2-man integrators, maybe some education partners that want to be able to weigh up where the future's going in AV over IP. So that's the thing. So
come to the right place.
We come to the right place.
Yeah, absolutely.
We're at the Atlona stand, so
why not?
Free plug in there.
The thing to try to remember about AV over IP, there's a lot to unpack, and there's a lot of mystery around it. So much of our industry, certainly for the length of time that I've been in it, we've always had to deal with a cable length limitation. You can only take a certain signal so far. In audio, of course, we balance the signal and we can run a long distance. Well, now that we have higher and higher detailed video signals, the HDMI cable can only go so far.
Yeah.
Now it works fine in an office, in a meeting room environment, but what if we want to take that signal and we want to span greater distances? What if we want to take it over maybe the whole enterprise? Well, logically, our friends on the telecommunications side learned that the telephone signal was best handled if we put that on to the IP backbone. And so that's why the telephone systems moved into the IT closet, as we would call it today. Well, the next natural evolution is to take this whole AV world that we work in, whether it's an AV signal for audio and video, maybe it's a USB signal, and why don't we put it on the superstructure, the infrastructure that's already there. So now we see AV over IP, over Internet Protocol, and that's a big mystery for a lot of people, right?
Yeah.
Because our industry, we're so used to just wiring this up to that, and I know how that switcher works, I know how that matrix switcher works, I know how the audio breaks out, but when I put it all into one category cable, then what happens?
Yeah.
Well, you're familiar with wireless microphones. You have a transmitter and receiver like we have here today.
Yeah.
We have to do the same thing with AV over IP. So part of unpacking that is understanding that you first have to get these signals onto the IP stream, and then on the destination side, you have to get it back out. So kind of like a transmitter and receiver, except we use the term encoder to get it onto the network and a decoder to get it off.
Yeah.
Right?
Makes sense.
And so we don't have to worry so much about what happens on that network side because we're using a standardized protocol. But one of the things that we do have to worry about is how do we pack that into the encoder? So the question of codecs come up. The question of how much bandwidth are we going to need comes up. So one of the questions that we get asked from time to time is, well, can I use it on my standard network? How much space are you going to take up? So you hear this conversation about a 1 gigahertz or a 10 gigahertz backbone, as the case may be.
Yeah.
How much can we pack down?
Don't mean to correct you, but it's gigabit.
I did. Yes. I did, yeah.
But that's okay. You're the sales guy, right? That's okay.
So perhaps this is a good segue for Reto.
Well, let's
enter Reto.
Yeah, so we're gonna do it because it's very ad hoc, right? Because
right.
another special guest has joined us. So I'm going to hand my mic over to you, Reto. I want you to tell us in a little bit more detail, technical detail of what codec your Atlona is using, why you're using it, and if you're using 1 gig or a 10 gig solution.
Thank you, Pete. So yeah, indeed, the first question is always 1 gig or 10 gig. Why? Because 10 gig doesn't scale. So we stay away from that. There are products there. There is even interoperability to some extent between these products. They might work on smaller projects, but they cannot scale from switch to switch. Imagine even a medium-sized higher education installation, they easily reach 20 signals that you want to send across a campus. So 20 times 10 gig, that's 200 gigabits a second. So you can buy these uplinks, but I haven't seen them so far. Yeah, good. So that's why we stay in the 1 gig. So in the 1 gig again, then you can have codecs with using lower bandwidths. So you can send them over Wi-Fi, you can do soft decoding on iPads and so on. Again, we decided not to go there. Why? Because we wanted to deliver the same quality experience that you get from a physical matrix switch. Like on HBase-T we go up to 16 by 16, and everything bigger than that, we strongly believe the future is IP. So that comes to scalability. So we don't have a single point of failure, we don't have a central chassis. We can add encoders, decoders as much as you like. If you don't have switch ports anymore available, you just add another switch. You pull a fiber uplink between the switches, and there you go. So with a standard 40 gig uplink, we can already send 80 signals in full HD resolution in visually lossless quality. So the codec we're using to deliver that is called VC2. Comes from Video Codec 2, standardized by SMPTE, has been developed under the name of DirectPro by the British BBC. It comes from the broadcast side of the market. So the characteristics is very, very low latency, so 8 milliseconds actually from end to end, which is industry first on a 1 gigabit technologies over IP. And also visually lossless is already achieved. The 1 gig pipe goes up to 4K P60 444. Even Dolby Vision at 60 Hertz, and we are the only IP solution actually supporting Dolby Vision at 60 Hertz. And that's due to the magic we did with the metadata. So Dolby Vision has dynamic metadata, and we're actually also sending those over the network. Yeah.
So just to unpack the compression here, there's a lot of bandwidth happening at 4K 6444. So we're talking up to 18 gig depending on the depth of bit color. Yeah. So what's happening to it? How do we get that into this tiny little pipe? Like,
It's called compression.
that's right. Yeah, but what's happening to the image at this point? You know, there's a lot of argument around the 10 gig versus 1 gig.
There is,
and the amount of compression that's happening here.
Thank you for the question. Actually, I'm very happy that even the SVOE friends, they stop bashing compression because they use it themselves. There is one AVoIP product on the market that doesn't do compression, but it's using a dual 10 gig link, so a 20 gig link. So yeah, I mean there is a market for that. Yeah. In events where absolutely zero tolerance on anything, like even a microsecond will be too much. Yeah. Okay, but it's not where we are actually installing it. We are in the installation market, meeting rooms, boardrooms, campuses, higher education. So there the 1 gig is a must, and compression is accepted as long as you don't see it. So there is no artifacts on the video, and there is no noticeable delay. Of course, you can measure the delay, like latency is 8 milliseconds, but hand-eye coordinating will just be fine. Yeah. So yeah, we are staying away from H.264, H.265 so far. How they can achieve these low bit rates, because they do iframes and B-frames. So again, that gives a lot of latency, like 500 milliseconds, a second, 2 seconds. We don't do that. We do iframes only. Not completely different than what JPEG 2000 is doing. Compared to what they are doing, basically we have a much lower latency, where they are at 30-35 milliseconds, we are at 8. But we use twice the bandwidth. So for a full HD, you can fit 2 streams in a gigabit pipe. For a 4K P60, that will be a full gigabit port.
You make a good point about latency, right? So I suppose that always depends on the application.
Absolutely.
So if you've got an application where you need effectively live, you know, you're doing a presentation, for example, you've got some confidence monitors around, might be an auditorium, a lecture theatre, that kind of thing. Low latency is important, right? Because it's live. But in some other cases, quite often, if you don't know the source, like you're not seeing the source, it could be, it could be 5 seconds latency, right? And it wouldn't make any difference. So latency is always an interesting conversation, because you can talk about having low latency. It's about, what are you trying to do with it? That's what it's coming down to.
Yeah, it's not so much that we are just offering low latency. It's more like we listen to the customer, what do you need? And if there is a professor on the stage and behind him is a projected image and that's out of sync, it's very confusing for the auditorium. If there is an overflow room and a student in the overflow room has a question, so they give him a microphone and a camera and he has a quick chat with the professor in the first room, if there is a lag, then it's like a very bad video conference that we all hate, where you wait and then everybody speaks at once and then you wait again. You don't get that experience. More and more we are doing training rooms, interactive things. We also have USB over IP adapters, so we can have touch screens. We do cameras, and people just expect when they touch the screen, it's immediate response. But that screen might get the content from the AVoIP system. So with OmniStream, we can fulfill that. We even go a step further and we do virtual reality. So we have a setup with goggles, where what you see on the goggles is over IP, and how you interact with your input device is USB over IP, and you don't notice that it's over IP because it's real time. The use case in that case was a university where they have students for architecture, where they build their simulations on their workstations, and at the end when they're finalized, they present their project in the real room. But that is far away, so they cannot always bring the workstation. So the workstation still runs the simulation, but the control and the audio and the video is over IP in real time.
And we had, like before AV over IP, the pseudo standard for the industry, for our industry, was HD base T, right? I say pseudo standard. It wasn't a standard. It wasn't a ratified standard, as we know. But with AV over IP, we seem to have so many different flavors in the market. Are we going to see a standardization, in whether it's an official standard or a pseudo standard in the industry, where we're going to have different manufacturers be able to talk to each other? So like even with HD base T, on a base level, different manufacturers, their products would talk to each other, right? You might not get all the bells and whistles that they offered, but at least you would get video, you would get audio. Are we going to see that with AV over IP, do you think?
Not on the short run. We saw it on the audio, and thanks to Odinate, they made a great job. Now we have AS67 on almost all of our products, so that works. Why does it work and why is it interoperable? Because audio is uncompressed. So everybody's talking about the same thing. So it's what you have to integrate is just basically the API and the discovery and the control and the routing, but the actual streaming it's always uncompressed and it's always the same format. In video, it's completely different. So, like you said, there's different customers have different use cases, different priorities. So the one is asking for lowest possible bit rates because he wants to soft decode it over Wi-Fi on a tablet, on a mobile phone. While where we are acting is like I said, is we want to replace the HDBaseT matrix. We want to bring that to the network. So we want to provide visually lossless video quality and not noticeable latency, and that is only possible at high bit rates. Our bit rate is even that high that a regular PC cannot decode it, so we don't offer soft decoding. So in between there lies all this variety of applications and best fitting product for each of these applications. So saying that, I mean, I cannot look into the future, but processing power obviously goes up. There is new algorithms. Already the VC2 is superseding the JPEG 2000 in terms of performance. JPEG 2000, hence the name, is released in the year 2000, developed like 98 or around that, so that's 20 years ago. It's an old guy, so in the meantime a lot of things have happened, and VC2 is taking advantage of that and providing better performance.
Yeah, so speaking of just to unpack the HDBaseT suite to really bring that back down to a installer level, and where do you see the sweet spot from HDBaseT? Like, because it's still, even just the price point for HDBaseT now is AV over IP is still more expensive than at say 8x8 or something along those lines. Or where do you see the sweet spot happening where it's logical just to go to AV over IP?
Again, it depends on the customer. So we have made nice installations in Australia, in some universities. They just went for the full IP solution, so they don't even have HDBaseT anymore. Everything is flat on the network, and then they can route from building to building over their campus. It works perfectly fine for them. Asking for a sweet spot, like I said, we have a 16 by 16, and that's the biggest one we have.
Yeah.
Because higher than that, yeah, makes sense. Also, we see more and more customers doing hybrid installations, so they have either a small or a medium-sized matrix in a room, and then they have just one encoder and one decoder connected to the outside world. So that's very cost-effective, actually. Hybrid system. Yeah, local switching, because sometimes you have just one projector in a room, and you just want to show that content somewhere else, like university.
You know, another way of looking at the sweet spot argument also comes down to the number of sources and destinations as well as the distance. So HDBaseT, we can get that to go 100 meters, right? But with an IP hop, we have multiples of that. So in some applications, let's say you have what we call a sports bar, where you've got a few signals that have got to go to a few TVs, but they're at great distances. Well, now you're looking at, maybe you be looking at AV over IP to meet that.
Yeah.
But in a meeting room with a few destinations and a few sources, again, we could probably do that over HDBaseT. So as Reto says, it's not only just a matter of scale, but it's also what's the environment called for, and sometimes a hybrid solution is a way of doing it, but also there's still a place for HDBaseT, and there's a place certainly for AV over IP.
Sure, and one of the interesting things is that both systems rely on the same cabling infrastructure, right?
Yeah.
So, and what I found fascinating was, maybe 12 months ago, Panjut, one of the big three real, players in the IT infrastructure industry, looked at Atlona and thought, that's a company that we want to own, and they acquired Atlona, which was, I've got a background in cabling, and it's like, wow, that's quite interesting that they see that there was some benefit to buy an AV company. Can you tell us a little bit more about that?
Absolutely, and it was really a benefit for both parties, but let's look at it from the Panduit point of view. If they're already working with these large multinational companies that are building their facilities and they're putting in, as you say, all the infrastructure for data center and such, well, the next logical extension for their integrator partners is, let's stay with that project and then go from just the data center. Now let's talk to the companies that put things on the data center. So Panduit took a long time to investigate this, in some ways started their own systems of let's get into AV and let's explore this and let's see if it's the right move for us. And then over a period of time, there were conversations with various manufacturers. Atlona was one of them, and there just seemed to be a great opportunity because from our point of view, if Panduit is already there at the infrastructure stage, then it makes perfect sense for us to want to be there earlier and earlier. So now Atlona is getting involved with the conversations at a much earlier stage now, so that the systems can be put in place for both the IT and the AV side of the equation. And that works out really great for both of us.
Yeah, right. So just to unpack the network part of this a little bit, we're seeing a lot, I don't know if you're seeing this too, Pete, but there's a bit of a point for AV guys there. They don't want to cross the line into IT. And certainly IT doesn't necessarily always want to cross the line into AV. So we're seeing a lot of transmitters and encoders and decoders put in on a completely separate network, which I understand.
When you say a completely separate network, you're talking about a VLAN, a separate VLAN, or actually talking about separate
completely
infrastructure,
hardware,
right,
infrastructure.
Interesting. Kind of defeats the purpose.
Kind of
it,
defeats
right?
the purpose, right? But for the AV guy, well, there's a lot of switches now that are coming out that have got drivers already built in. You just go bang, deploy that, and it's easy. But all we're doing is recreating the HD-based matrix.
What's the point of switching over? You may as well stick with HD-based if you're going to put in your own cable infrastructure and your own switches and things. I think that's the power of AV over IP, is that cabling already exists, the switches already exist.
Yeah.
Let's utilize it. It's like putting in what I find a little bit crazy, since in the US, we're finding it in some of the actually nearly every telecommunications room, they've got 110 volt and 240 volt going in to support the different products that are being installed. Can we just, you know what I mean? It doesn't make sense, right?
Yeah, it doesn't make sense. Yeah, that's the real challenge. So we're going to see a lot more requirement for AV to have skill set in IT going forward, yeah? Fair to say.
That's true. I'll address the question about separate networks for the two different disciplines. It really comes down to best practices and also that company's sense of security for their data. Within most companies, data is king. You've got finance running down that data that absolutely positively has to get to the CEO's office. And so historically, a lot of these IT folks are a little concerned about AV taking up their bandwidth. And while we can travel on that same network by design, as Reto talked about, having our backbone being compatible with the existing backbone, that allows us to do that. But again, best practices often allow us or require us to be on a separate network, whether it's for security or whether it's just ease of operation. You've probably no doubt seen many of those applications yourself.
Reality actually is, I get the question a lot. Do you require separate VLAN, separate switches? Well, we are agnostic. If you know what you're doing, you can put the same stuff on the same VLAN everywhere. That's what we're doing on the show. AVoIP, Dante, Control, everything is running on the same VLAN. As long as it's properly set up, it can be done. Also, what some customers in Melbourne did. But it needs then segmentation, IGB carriers and so on, depending on how much stuff is happening on your network and where do you want to send the streams to. So we can do that.
And does Atlona offer training to installers and integrators to teach them how to set it up for a network? Are you wanting integrators to do it? Do they have the right skill sets at the moment, or are you looking elsewhere, maybe for IT professionals and trying to educate them? Or are you doing both?
For sure, we are doing both. If we get a chance to advocate someone, it's you have to learn it. It's your future anyway. If you block yourself out of that, that's not going to good for your business in the near future. We do offer training. We start with an online training to talk about the basics, and then we do factory trainings in various locations around the world. We just recently opened new locations, so we already had in US, California and Chicago. In Europe, we had Switzerland and Germany, and now we also open up London, so in England, and then we have Singapore and Shanghai, I think, these two. So there we have 42 trainings happening this year around AVoIP control system and HCBC, because HCBC, there's still a market for it. It still works. We just bring USB to the HCBC, which actually leverages the usability a lot for video conferencing system. We also bring USB-C. So with a single cable, you can connect your laptop, you can send audio, video, you get the cameras, the speakerphones, even the DSP if there's any. So there is a lot of stuff happening, and we talk about this in trainings. Yes, yeah. Very important. Good point.
All right, we've unpacked a bit.
Quite a bit.
We have. Yes, that's been very good. Look, and we're here all week at ISE. We're going to go around. We're going to talk to a few other manufacturers and industry experts and unpack AV over IP with them and get their thoughts on the whole thing. And so we really appreciate your time. It's been fantastic. I think we've learned a bit, and hopefully the people back home have learned something at the same time.
Yeah, absolutely.
So,
beautiful.
Thanks guys. Stay tuned. The Tech Effect. We're here all week. Subscribe to our channel, and we'll talk to you soon.
See you guys.